All right, class. Sorry I'm not there today, but hopefully you're in good hands with the substitute and that you were able to go through that demonstration of what a radian is that was also on the Canvas page. If you recall from yesterday, well, first of all, let me backtrack a little bit. What I would like you to do is to, at some point, pause this presentation so that you and the person you're sitting next to can share one iPad and this video as the lesson, and the other person can take some notes. So you will find a copy of the handout for this presentation also on the Canvas page right below the link for this video. So pause it, make sure you have all that set up where one of you has this video to watch on your iPad and the other one has a copy of the PDF in Notability to take notes on. Then when you're done, the person that took notes can share it with the other person or email it. So get that done, please, and then we will continue. If you recall from yesterday, we had an experiment similar to that video or that GeoGebra that you did, where we were talking about the number of radians around a circle. And many of you came up with 6.25, maybe 6.5. Someone had 7. And then there was the video, and we said, or the GeoGebra that you had just done, and that was about 6.28. Right before the bell rang yesterday, I asked, what is the area of the circle? What is the circumference? And the circumference of a circle was 2 pi times the radius. Now that 2 pi, if you plug that into your calculator, actually comes out to be 6.28, which is the number of radians or radii that you could fit around a circle, times the length of a radius. So if you want to find the circumference of a circle, and hopefully this will make more sense in terms of the formula for the circumference, you have a circle and it has a radius of, let's say, 2. And you know from yesterday that you can take about 6 of these and fit around a circle. So one of those radii might go right about there. Another one would end there. Another one there, so that's 3. And so there's 4, there's 5, and there's 6. So you have 1, 2, 3, 4, 5, 6.28 radii. Well, each radii is 2 units long, times 2 gives you the circumference of 12.56 units. So what we're actually trying to tell by looking at this circumference is that the distance around any circle is always going to be 2 pi times the radius. Well, if your radius is 1, then the distance around the circle is exactly 2 pi. What that allows us to conclude is that in 360 degrees, all the way around the circle, we have 2 pi radians. In 180 degrees around the circle, that would be just halfway. So let's look at just going halfway. Well, if it's 2 pi all the way around, to go halfway, we have pi radians. And if we're just going to go 90 degrees around the circle, which is up here, that gives us a 90-degree angle. Well, half of pi is pi over 2. And as a bonus question, pause this and answer, how many radians is it to get to 270 degrees. So pause it and answer that with your partner. Hopefully you had a chance to answer that. And if this is pi over 2, and if this is pi radians, and this has to be 3 pi over 2. And all the way around then, we're at 2 pi. Now let's continue on to the next slide. How is a radian related to the radius? Well, 1 radian around a circle is 1 radius. And let's continue to the next slide. So they want you to draw each angle on its own unit circle. So let's draw a circle and axes for part A. And that's not a good circle. That's maybe just a little bit better. And 1 degree. How much is 1 degree? Well, there's 360 degrees in a circle. So I don't even know if I can be as accurate as with a stylus as I'm supposed to be with 1 degree. But that would be about 1 degree, starting at the vertex or at the origin. And that might be 1 degree for an angle. But now in part B, for 1 radian in a circle, well, if there's 6.28 radians in a circle, then that would be right about there, and this would be 1 radian. And for part C, oh, that looks familiar. C, we have to do pi radians. Well, on the previous, or a couple slides ago, we talked about pi radians. It's 6.28 radians. Remember, it's 6.28 radians all the way around. Don't draw that. 6.28, which is actually 2 pi. And so halfway around would be pi radians. So that would be starting right there and going all the way to here. That angle would be pi radians. And we talked about where pi over 2 would be also. So in part D, if I'm going to do pi over 2 radians, well, that's half of what we had up here in part C. So that's going to be right there. So there's pi over 2 radians. That's my angle. And that's pi over 2. Part E, well, pi over 4. Well, if I take half times what I had over there, so half of the angle in D, that's going to be pi over 4 radians. So in part E, here's my circle. Half of pi over 2 radians. So that's my angle right there for pi over 4. Pi over 3 radians. As a group, I would like you to pause this and discuss where you think pi over 3 would be, and in part G, where you think pi over 6 radians would be. So go ahead, pause it, answer those questions, make your sketches, and then resume play. Okay, hopefully you were able to make those drawings. Pi over 3 is going to be somewhere between pi over 4 and pi over 2. What we're doing is, think about this. We're taking pi, which was again in part C, and we're going to divide that into thirds. So if I take pi and I divide that into thirds, boom, boom, this would be pi over 3, this would then be 2 pi over 3, and this would be 3 pi over 3. So our angle right here is pi over 3. Pi over 6 is half of pi over 3. So if you take your angle in F and you half that, you're going to get pi over 6. And that's this angle right there. Now these are radians. And what we're saying is if you were to take pi, which is 3.14, and divide that by 3, you're going to get 1.04. So just a little bit more than 1 radian. And that means we're going to have a little bit more than 1 radius going from here to here. Pi over 6 is about 0.52. What that is saying is if I take my radius and I half that, that's going to be this same distance along the edge of a circle. So now, excuse me, 2 slides before, this pi over 6, that's almost the same as 30 degrees if you take a look at your unit circle. In fact, it is the same as 30 degrees. Pi over 6. The next slide. They want you to find your sign calculator. That's the yellow sheet that I gave you yesterday. And we want to relabel our units on the theta axis and change it from degrees to radians. So I'm going to do the first one or two, and then you can resume from there. All right, so relabeling this in terms of radians. We have degrees, and I'm just going to draw a line. Maybe I should make it a different color, maybe a highlighter. Might be a little bit better choice. I'm going to highlight the degrees in green. Then, in red, we're going to write down radians. We know that 360 degrees is 2 pi. We also learned that 180 degrees halfway around a circle is pi. And that 90 degrees was pi over 2. And as a group, you discussed what was 270. Well, that's 3 pi over 2. So labeling some of these other angles that are on here, we have 30 degrees and 60 degrees, and then 120 and 150. Well, if you go back to our previous slide, And so 30 degrees is the same as pi over 6. Now if you take 30 degrees times 2, you get 60. So if I go up here and I take 30 times 2, I get 60. Well, if I take pi over 6 times 2, this is going to become pi over 3. And now just playing around with some of the ideas that are here, if I doubled pi over 6, took that times 2, so pi over 6 times 2, that gave me pi over 3. Well, what if I take pi over 3 times 2? Pi over 3 times 2, because 60 times 2 is 120. Pi over 3 times 2 is 2 pi over 3. And you don't have to just do it by multiplying by 2 to figure out what some of these other angles are. Think of it like this. Also, you got 30 degrees. Maybe 30 times some number gives me 150. Or 30 times some number gives me 120. Or 30 times some number gives me 90. So like 30 times 3 gives me 90. So I could take pi over 6 times 3, and that's going to give me pi over 2. So 30 times 5 gives me 150. So in the radian mode, so if I take that idea of times 5 and do it in radian mode, I now have pi over 6 times 5 which is equal to that is equal to 5 pi over 6. So what I'd like you to do now is to pause this and as a group discuss how you're going to find the radian measure for 210 degrees, 240 degrees, 300 degrees, and 330. And then when you're done, come back to it, and I will have the answers written in, or I will write them in with you. Okay, so hopefully you are back now. 210 degrees, one way to get that is 7 times 1, or 7 times 30 is 210. So 7 times pi over 6 is 7 pi over 6. Another way to get that is to understand that pi is 6 pi over 6, and I need to add another 30 degrees, or add another pi over 6. And that's going to give me 7 pi over 6. Now to get 240 degrees, that's going to end up being 4 pi over 3. And using something similar to what I did down here for the 7 pi over 6, I'm going to take 180 degrees and I'm going to add to it 60 degrees. Well, 60 degrees is pi over 3. So if I take pi plus pi over 3, pi is the same as 3 pi over 3 plus pi over 3 gives me 4 pi over 3. Now to get to 300, there's a couple of different ways to do it. I'm going to talk about taking pi plus, that's 120 degrees. Oh, look at that. So if I go from 180 to 300, I'm adding 120 degrees, which is 2 pi over 3. So I'm going to take pi plus 2 pi over 3. Well, pi is the same as 3 pi over 3 plus 2 pi over 3. Gives me 5 pi over 3. And finally, 330. I'm going to try to give you a little bit different perspective on this. One way to get the degrees in 330 is to actually say, hey, this is going to be 30 degrees less than 360. So if I'm subtracting 30, I'm going to take 2 pi, in terms of radians, I'm going to take 2 pi and subtract pi over 6. Well, this is the same as, with a common denominator, 12 pi over 6 minus pi over 6, which then is 11 pi over 6. Now this basically concludes lesson 7.1.5. Sorry about skip that. That's a little. And in order error. So recapping, more efficiently upload things. I'm going to stop this, save it, and then I'll start a second video for 7.1.6. Just to quickly recap, if you take a look at this slide, a radian is defined as an angular measure. In other words, 1 radian equals 1 radius laid out along the perimeter of a circle, meaning we have 2 pi radians in a complete circle.